A modern cargo ship can carry 24,000 containers across an ocean using less fuel per ton than a truck. Yet a single blocked canal can halt $10 billion in trade per day. We built a world that runs on perfect math until reality adds a variable the equation forgot. Chapter 1: The Illusion of the Frictionless Machine. We are taught that the pinnacle of a smart system is efficiency. Less waste, tighter timelines, lower costs. A just-in-time supply chain doesn't pay to warehouse parts, it receives them as the assembly line starts. A bank doesn't sit on piles of idle cash, it lends it out to generate returns. A corporate team isn't bloated with redundant roles, it's lean and agile. The metrics celebrate this. Higher throughput, better return on assets, improved productivity. The system is rational, optimized, and beautiful on a spreadsheet. The incentive structure here is powerful and one way. Who benefits when it works? Almost everyone. Shareholders get better returns. Consumers get lower prices. Managers hit their performance bonuses. The system rewards those who squeeze out more slack, who reduce that wasteful buffer. But the losses for failure aren't borne by the same people, and they aren't felt immediately. They are diffuse, delayed, and often catastrophic. The cargo ship companies saved millions on fuel by building ever larger ships. They don't personally pay the $10 billion a day when one gets stuck. The pressure to show quarterly growth will always outweigh the abstract, statistical risk of a once-in-a-decade crisis. So we've built a global machine where the incentives for efficiency are concrete and immediate, while the penalties for fragility are abstract and deferred. This isn't a mistake, it's the output of a perfectly rational system playing by the rules we gave it. But this is only what you see on the surface. The real mechanism of failure is what happens when the clockwork meets a wrench. Chapter 2: The Hidden Tax of Resilience. When you optimize a system for peak performance, you're almost always consuming its redundancy. Redundancy is capacity that isn't used in normal operations. It's the extra lane on a highway that only fills during rush hour. It's the backup supplier you pay a retainer to, even though you mostly use your primary. It's the cash reserve in a bank that isn't loaned out. In an efficiency-focused model, this looks like waste. It's idle capacity, a cost on the balance sheet that isn't producing a return. So the system, following its incentives, gets rid of it. Here's the math check. The math of efficiency is simple. Output divided by input. To make that number go up, you increase output or reduce input. Redundancy is pure input with no daily output, it gets cut. The math works perfectly, right up until the moment it doesn't, because you haven't actually eliminated the need for that capacity. You've just hidden it. You've traded a steady, manageable cost. The price of a backup for a sporadic, enormous cost. The price of total collapse. Let's make it concrete. Think of a team of 5 people handling a workload that takes 100 hours a week. An efficient manager sees each person working 20 hours. We can handle 25% more growth. But this is peak efficiency at exactly 100 hours of work. What happens when one person gets sick? The system is now 20 hours short. The work doesn't disappear. The remaining 4 must work 25 hours each. That's a 25% overload. Stress increases, errors creep in. If a second person leaves, the system implodes. The efficient system had 0 capacity to absorb shock. The resilient system would have had 6 people for that 100-hour workload, looking inefficient at about 17 hours per person, but capable of absorbing the loss of 1 or even 2 members without failing. The COVID supply chain shock was this on a planetary scale. Systems optimized for low cost and perfect timing had no buffer for a port closure, a factory lockdown, or a surge in demand. The best practice of single-source suppliers and lean inventories backfired spectacularly because the practice was only best for the narrow condition of steady-state operation. The real shocker is that the people running these systems often knew the risk. But the incentive structure, the pressure from markets, boards, and competitors to show ever-improving efficiency numbers made it irrational for any single player to unilaterally build in costly buffers. They would be outcompeted by those who didn't. Chapter 3: Cascading Failure and the Ritual of Control. Under pressure, a lean system doesn't gracefully degrade, it experiences cascading failure. One small breakage creates disproportionate downstream effects because there is no slack to absorb it. A delay at one port doesn't just slow down one ship, it creates a queue that blocks the port for others, which then miss their next scheduled port call, creating a global schedule meltdown. A liquidity crunch for one bank doesn't just trouble that bank. Because all banks are similarly leveraged and interconnected, it triggers a panic about which bank is next, freezing lending across the entire system. This is where best practices often become dangerous rituals. In a crisis, management's instinct is to double down on control, to demand more data, hold more meetings, and centralize decision-making. But this is precisely the wrong response when the system is suffering from a lack of local adaptability. The rulebook was written for the normal state. Following it during a novel crisis is like a pilot, having lost an engine, meticulously continuing to follow the pre-flight checklist. The procedures are meant to prevent error in a known environment, not to invent a solution in an unknown one. Operational reality diverges from the plan. Frontline employees see the problems first: the truck that never arrived, the payment that stuck, the component that doesn't fit. But in a hierarchical, efficiency-optimized system, they often lack the authority or the spare resources to improvise a fix. They must escalate. Information must travel up a chain of command where managers removed from the concrete problem try to apply abstract policies. By the time a decision comes back down, the problem has often multiplied. The system designed for smooth operation actively prevents the very adaptation it needs to survive. Think of a bank during a liquidity crisis. The best practice of daily balance management and high-yield lending is what got it into trouble. The practice for the crisis selling assets to raise cash is exactly what every other bank is trying to do simultaneously, causing asset prices to crash and making the crisis worse for everyone. The individual rational action leads to a collectively irrational outcome. The system has no protocol for this because it was optimized for individual competition, not collective survival. Chapter 4: Building the Anti-Fragile Mindset. The solution isn't to abandon efficiency for chaos, it's to consciously and strategically redefine what you're optimizing for. You must shift from optimizing purely for output in a predictable world to optimizing for adaptive capacity in an unpredictable one. This means deliberately designing in slack, diversity, and modularity. First, slack is not waste, it is options. You must reconfigure the math, that extra cash, that idle capacity, that overlap in skills. This isn't a cost to be minimized. It's an insurance premium. It's the price of having options when your primary plan fails. The calculation changes from what does this cost us per quarter to what is the cost of not having this when we hit a 1 in 10-year shock. The 2008 financial crisis showed the cost of no slack in banking. The firms that survived were famously fortress balance sheets with higher capital reserves than their peers. They looked inefficient in good times. They were the only ones standing in bad times. Second, diversity over homogeneity. A system dependent on one perfect supplier, one transport route, or one type of financial asset is a system with a single point of failure. Redundancy means having multiple different pathways to the same goal. It means dual sourcing parts from different regions. It means building a team with overlapping but not identical skill sets. It means a financial portfolio that doesn't all move in the same direction. Homogeneity is efficient. Diversity is resilient. Third, modularity and decentralization. A monolithic system fails all at once. A modular system can fail in parts. If one module breaks, it can be isolated, and the others can keep functioning. This means designing supply chains where a disruption in Asia doesn't halt production in Europe because you have regional hubs. It means corporate structures where business units have the authority and resources to solve local problems without waiting for headquarters. You trade some central control for a huge increase in overall system robustness. Implementing this requires a brutal honesty about incentives. You must align rewards with long-term survival, not just short-term gains. This might mean rewarding managers for maintaining healthy capacity buffers, even if it hurts quarterly margins. It means investors valuing stability and durability as much as growth. This is the hardest part because it goes against the grain of decades of financial and operational theory. But the alternative is a world of breathtaking efficiency punctuated by episodes of catastrophic collapse. Chapter 5: The Fragile Crystal Palace. We are left with a central, unresolved exposure. Our global infrastructure, financial, logistical, corporate, is more interlinked and optimized than ever before. This has given us incredible wealth and convenience, but it has also raised the stakes of failure exponentially. A shock in one optimized node now propagates at light speed through the entire network. We have built a spectacular, precise, and incredibly fragile crystal palace. The forward pull question isn't if the next stress will come. It's which of our beautifully engineered systems, humming along at peak efficiency today, will be the first to discover the price of the slack it decided not to pay for. If you want to understand how the machines of our world really work and where their breaking points are hidden, follow and subscribe.